All right. Good morning, everyone, and welcome to today's webinar. Um, I'm actually in a little different setting today than I normally am. So usually I'm in Portland where I live. I work remotely for Nexa 3D. Today I have the pleasure of doing the webinar from our office in Ventura. So a little different backdrop for me. But yeah, today we got a really cool topic. We're talking with Paul Cilino, founder of MotoCilino, about his experience so far with XiP and getting to the crux of why he made the switch from his previous SLA resin 3D printer, and the results that he's gotten, which you could see on the title. A lot of speed improvements in addition to some other things. So we'll talk all about that. But hey, how's it going, Paul? Welcome to the webinar.
Oh, thank you for having me. Good to be here for sure.
Cool, man. Well, Paul, if you could, I'm just going to ask you to give a quick intro, a little background on yourself and MotoCilino.
Yeah, absolutely. Again, thanks for the opportunity to speak to everybody out there and to be part of the webinar today. Yeah, so my name is Paul Cilino. I work as a small engineering design technical services company serving clients who really are in a variety of different areas, but the mainstay of the business is the 3D CAD modeling, 3D scanning and reverse engineering, and 3D printing for prototyping and for I guess for form, fit, and function type validation of designs that we use for our as part of our design process.
Cool. Yeah, so you're kind of a small design consulting firm. I'm sure, I know there are probably people on here who do something similar. I think it's a really cool to see. Like we have obviously a lot of engineers here at Nexa. They work in the lab. It's not always so easy for them to work from home and because all their tools are here. But obviously you've got some 3D printers to allow you to do maybe a little bit more stuff from a hardware standpoint than maybe was possible 10 years ago or something like that.
Yeah, so really at the core is this idea of being very technology dense and offering a pretty wide swath of capability to clients, starting from conceptual modeling to being able to hand them a finished prototype.
Sweet. Cool. Well, before we get into kind of the meat of the conversation, I do want to let people know a little bit about Nexa. If this is your first time joining one of these with us, welcome. If you're returning, thanks for coming back. And yeah, if you want, go ahead and let us know where you are coming from, where you're watching this from right now. Tend to get people from all over, so I always like to see that. Like I said, I'm in Ventura. Paul's in Georgia, right, Paul?
Yes, sir. Atlanta, Georgia.
Atlanta, Georgia. Heck yeah. So Nexa 3D, quick background. We like to say we're building a sustainable digital supply chain through additive manufacturing. So we're enabling that. I think prototyping and product development is a huge piece of that. Just enabling engineers like Paul to be able to quickly realize their ideas. But also on the manufacturing side, this idea that with ultra fast 3D printers, it's becoming more and more of a reality that you can produce low, even like medium-ish volume runs now with these 3D printers, have them done in a day, and get all the flexibility that comes with that, reduce lead times compared to maybe ordering very high quantities from overseas and stuff like that. So that's kind of what we mean by that. We've got a full range of 3D printers, as you can see on the screen. But today we're going to be focused in on XiP, which is the one Paul has. All of our printers are designed and manufactured right here in Ventura, which I think is another really cool thing. And like Paul, there are many diverse customers from all different business sizes and industries that are using our 3D printers already. And everybody really, they have a common need for speed. They want the fastest option out there, and so that's what we're aiming to provide. And let me see here. So thanks for chatting, by the way. I'm going to read some of those out, but I do want to launch this quick poll to ask another question. So now that you've told me where you're from, can you maybe I'll let everybody tell me a little bit about their situation as it comes to 3D printing, which best describes you. I'm interested in getting my first 3D printer. I already have a 3D printer, but I could use an upgrade or an addition. I already have all the 3D printers I need, or I'm just curious about 3D printing tech, but don't really have an application for it yet. So I'll give you about 5 more seconds to fill that poll in, and then we'll throw the results up on the screen. 3, 2, 1, cool. All right, and so here are the results of the poll. So it looks like most of you already have a 3D printer, but could use an addition or an upgrade. Couldn't we all, right? I think it's the technology is constantly changing, so it's easy to have dated technology quickly, right? All right, I'm gonna stop sharing that. And I'm going to stop sharing actually my screen here, because today we are going stand slides. We're just going to have a little conversation one-on-one with Paul. And if you guys have any questions, by the way, go ahead and drop them in the Q&A panel or into the chat. Love to see those. Let's see, we've got people from all over the place: South Carolina, Ron, Virginia, Orlando, Florida, United Kingdom, bunch of other people from California. So glad to have you all here, and thanks for tuning in. And yeah, like I said, please participate, ask questions to Paul about his experience, and maybe we'll pre-answer some of those in our conversation. So, all right. Enough that housekeeping nonsense. Let's get into the conversation here. You ready, Paul?
Yeah, I think so.
Cool. All right. So first off, I just want to start with a little bit of background on your maybe a little bit more depth about yourself, where you kind of come from, how you kind of started your business, and maybe a little bit about your background in 3D printing specifically.
Okay, sure. So my name is Paul Cilino, and I'm originally from West Texas, and I sort of have a long history of being involved with our family business, which was a small job shop out in West Texas originally. And so that was sort of an entry point into machining and design, I think. Later went to college for mechanical engineering at UT Austin, and eventually after graduating, went back to work in the family business for a period of time, for I guess it was, I don't know, 6 or 7 years back in Texas. And just such a valuable experience, being able to work in that job shop environment, and come up in that job shop environment. I think you get intimately acquainted with some of the issues of certainly how design impacts manufacturing, and can come to bear on that directly. After going back to my hometown for a period of time to work after college, moved to Atlanta, actually, to work for Georgia Tech as a research engineer. And that was a really great opportunity to be part of some exciting research there to develop new 3D printing processes and some very unique applications for ceramic SLA sort of process that those researchers and that some of those graduate students were part of. Eventually, that work came to an end, and I sort of had the inclination to take the skills and the experience and to operate independently and to use those skills to solve some problems specifically in motorsport is where I started, and that's sort of the heritage of my business was taking sort of the design capability and the history and that skill set and combining it with a passion for motorsport as an amateur motorcycle road racer and knowledge of 3D printing, of 3D design, and being able to leverage those to solve some problems that I encountered as a participant in that sport, and to try to innovate, try to bring some innovation to a niche market that was that I thought could benefit from having some problems solved cleverly through additive solutions. What I realized during the evolution of the last several years of working that way was that, gosh, you could solve problems in a variety of spaces, not just motorsport exclusively. And so in the last several years, have opened that capability and those resources up to serve customers and consumer product, challenges and new product development in that space. Outdoor recreation. I have some clients who are in aerospace and some other various sort of entrepreneurial customers, small, inventor type customers that I work with very closely to help bring their concepts to life.
Awesome.
Yeah.
Cool. So so you started your MotoCilino in around 2016, is that correct?
Yeah, I believe it was September, October 2016.
Okay, cool. So, and then since then you've acquired a handful of kind of desktop 3D printers that you've been using to do all kinds of stuff with.
Yeah, initially, it was kind of interesting because there's certainly no shortage of, I would say, hobbyist level options out there. I'm trying to find something that is at an accessible price point that is still going to be capable and let's say dependable enough, sort of tending away from being a science project or a hobbyist kind of setup to something that you can sort of walk up to and get a print much more often than not, right? And so and something that's relatively small, right? The larger systems are, those require serious infrastructure to support, right? So an office friendly type system was something that is a better fit in this arena, I think.
Gotcha. So yeah, can you tell us a little bit about like what your journey has been? Maybe a little bit of background, kind of pre-XiP, like what kind of 3D printers you had before XiP?
Yeah, so the very first thing out of the gate was a small FDM system. Well, actually, a couple small FDM systems, and the project that sort of created an entry point for that was a decently sized silicone cast part for the customer who was actually in health and beauty. And we needed to work with some organic shapes, and so being able to iterate, and produce these shapes as she was in sort of the prototyping phase was important, and it created an entry point, a natural entry point for a 3D printer, and that was where I started off, right? So, friendly enough, didn't require a lot of support resources, and it was a good starting point for that project, but specifically to start developing capability.
Cool. All right, so a couple FDM machines to start.
Mhm.
I know you at some point you did get a resin, an SLA printer, specifically a Formlabs SLA. What was the reason to adding the resin into the mix
Yeah,
of the FDM printers?
great question. So really, if for those that are well familiar, FDM has its use cases, but small intricate detail is probably not the best fit for FDM, and so that sort of tilts the balance, at least application wise, toward something like SLA that can produce intricate detail on a smaller scale. And so after looking around, it would have been, I think, late 2017, 2018, I was approached by a client that was developing a product in dental hygiene. And the pieces were quite small, right? There was no way that FDM was going to work. And they approached me. They said that they had previously worked with a designer who was using Formlabs. And so they were quite comfortable with that. And it created a natural opportunity to stride in that direction for them to support their work. It fit, I think, hand in glove with a strategy for growth, to be able to offer these services on a continuing basis to other clients in the future. There were some realizations, right? And that's always sort of an interesting thing. It's there's a lot of talk about capability for these processes, but there can be an inconvenient realization of the limitations sometimes.
Cool. Cool. And then I guess that brings us to XiP. So tell us a little bit about like your process and kind of doing your research and what kind of created that need for you to give XiP a look or that technology.
Right. So to kind of build off the previous remarks, the Formlabs system, and Formlabs has done quite a commendable job with their system and for serving a market and serving it well. After that project with that particular client, there's a overarching kind of goal to develop products and produce them on demand for a product line of my own. But there are material limitations, right? And especially with photocurable resins, there's a different use case perhaps compared to thermoplastics out of FDM. And again, part of a longer term growth strategy was this idea of being able to use photoelastomers. Okay. And so that was kind of an appealing opportunity or possibility with that system. But the realization was that using the technology that is the foundation of the Formlabs machine kind of meets a limitation on that elastomeric, trying to work with those materials, right?
Okay.
And that's sort of tied, which we can come back to later. That's tied to, I think, the technology that is the foundation of their machine and their system. The system that I have was a Form 2. They've since released a Form 3 as the successor. But the Form 2 that I was using was still functional, still working, and still able to run parts. But it was clear that they were going to sunset that system, right? It was gradually going to be obsolete and no longer supported. And so that sort of prompted the idea of, okay, what would the next system be? And that started a whole, I guess, endeavor to understand what the options would be and what would make a sensible choice, either to leverage existing resources that were supporting the Form 2, but something that could be put in place and that wouldn't as painlessly as possible, right, as a replacement. And that sort of launched the search for an option, or for options, plural, right? Still, it's pretty clear that I had a need for intricate small scale geometry and for high detail and smooth finishes. And so that immediately, again, I think suggested that SLA might be another SLA system would be a good option. And so that is what kind of initiated that search.
Cool. And so yeah, the Form 3 was pretty new around that time when you were looking. So it seems like that would have been the obvious direction to just upgrade, stay within the ecosystem, so to speak.
Yeah, and you know, that was the inclination, right straight away. The unfortunate, you know, however you want to describe it, was that a lot of the consumables that I had stacked up to support the Form 2 on an ongoing basis and be able to easily put multiple materials in play, you know, keeping them on tap. A lot of those build trays, right, were going to be obsolete. They weren't, and that was, I mean, that wasn't a small amount of investment to make to be able to support customers with you know, short order, you know, sort of material on tap kind of requests. And as I began to dig into how the Form 3 was different, I wasn't strongly compelled that it was the best choice. I knew that I was going to have to invest kind of, you know, quote unquote retooling to some extent. But overall, I felt like the biggest gains were sort of incremental, right? And speed, the more that I spoke with, you know, some people at Formlabs, the speed wasn't, you know, it was better, but it wasn't night and day kind of different from what I was able to understand in our conversations. And so, you know, okay, there's an incompatibility issue with some of the consumables. There was a mild improvement speed-wise. And at the end of the day, there were still some unique ways that they implemented that technology that were still going to force me into what I felt were some limited abilities to use elastic formulations or elastomers, right?
Right.
And again, those are things that I thought I recognized from the conversations, you know. But again, there was this idea of, you know, familiarity with Preform and their software and their slicer. So there was some inertia there that represented a pain point, right? I didn't want to step outside of that and have to be exposed to uncertainty. And so we looked at some options, and did reach out to Nexa 3D for some sample parts on the NXE 400, which I believe is the flagship system. And it really showed some promise in terms of being a workhorse for productivity, right? And for speed, for sure. But it was maybe a little bit less accessible of a price point. And without, let's say, continuous or ongoing work to support that would be more difficult to support, right?
Right. And just for context for people, what Paul's talking about, the NXE 400 is, you know, it's our industrial, you know, LSPC. That's our technology. It's our industrial resin machine. You know, I'd say it's roughly the size of a refrigerator, and it costs about $60,000. So just to lay that groundwork for what Paul is talking about.
Yeah, and I think that in some cases, for sure, if you're a professional industrial service bureau and you have a consistent ongoing need, that definitely is a pretty formidable option, right? but as a small, slash, home office, small office kind of provider, it would be difficult to support that. So we looked at, again, that began kind of an extended search to understand what options to form 3, although it was never ruled out completely, right? And then I think it was 20, gosh, was it 21 that the ZiP was announced? I think
Like
late 21.
end of 21.
Right. And so here I am kind of poised to make a choice, and was familiar with Nexa 3D's technology. And then I heard about this very interesting high-speed system that was a smaller footprint and that at a price point that was right around kind of what was under consideration. And so as I had begun to kind of understand what the technology was, some of the key benefits, I had signed on for a early, waiting list to get a system. And along with that was the idea that it would substantially contribute to overcoming some of these other limitations, as well as open the doorway for actually production, right? You're talking about speeds now that, and some fundamental differences in the technology compared to the alternative being Form 3 that could potentially open the door to, production of, or small volume production.
Yeah.
So that's I would say the general arc of that story.
Cool. So you pulled the trigger on the ZiP. You've got it now.
Right.
Let's talk about like some of those differences. So I think the most obvious one is ZiP is not actually an SLA printer. It's an MSLA printer. Form is an SLA printer. So can you explain those differences? Because you're pretty up to speed with both.
Yeah. So fundamentally, what we're talking about is there's a gain in speed and in throughput straight away, just by virtue of an MSLA style, exposure strategy, right? You're talking about exposing the entire field with, a uniform distribution of light, okay? And fundamentally, at the end of the day, the Formlabs, let's call it an inverted SLA system. You're steering a single laser beam to hit a spot in that layer and expose it, sort of sequentially, right?
Mm-hmm.
And so, there's right away, fundamentally a speed advantage just by virtue of the fact that you're talking area-wise versus, a moving point. You're going to see a difference there. The other immediate difference is that there's a peeling motion in the Formlabs system, and that occupies time, right? That if you're talking about hundreds or thousands of layers, that adds up substantially. And so that isn't necessary with the ZiP. That's been done away with completely. There's one moving machine axis, and that's it. So there's no peeling, there's no intermittent or intralayer shearing action that needs to happen to separate from the exposure surface at the bottom. It's very straightforward and very quick, just by virtue of the way that these two different methods work, right? So those were some key considerations to think about.
And that is so like what does that translate to in terms of like throughput for that you've seen?
Well, so in the project and in the components that initially we started with using the ZiP for, right? The very first ones, we saw a reduction in cycle time of almost 5 or 6x. It was substantial. Wow. Went from 13 hours runtime down to, I think it was 2.5 on that part.
Wow.
There were other, I mean, there were other contributing things that allowed that, that enabled that, right? The ZiP has a wider aspect ratio, so it's rectangular as compared to the Formlabs, which is square. And so because of that, and because of the shape of the part we were processing, it was possible to tip that in an orientation that allowed, you know, a smaller build height overall. Okay, and so that was enabled by the aspect ratio of the build platform in the build area. But there's just no denying that the material, specifically the Pro 410, running on the ZiP, is blazing fast, very quick.
And the ironic thing of you know, getting that benefit of tilting apart to reduce its height, when it comes to ZiP, that MSLA tech where you're printing the whole layer, it really all comes pretty much, I mean, that's one of the biggest variables for the print time. So if you can get your part like flat or close to flat, you know, you can reduce the number of Z layers. It's printing the whole area in one motion. Like if, even if you had that more, I guess, that wider footprint on the form,
Right.
you would still need a laser to zip around and draw out the part, right? So it's not.
Yeah, and to be, you know, very, very fair in the comparison, you know, or let's say modern, you know, the Form 3, right, which is
Yeah.
they did implement different technology in that system. They chose to sort of modularize their optical train in a way that still requires, you know, a machine axis to traverse it from one side horizontally to the other along an x-axis.
Right.
And I just felt, you know, from a design perspective, and you can argue it, I think, quantifiably as well, that leads to, let's say, diminished or let's say lesser build speed compared to an MSLA style machine that exposes the whole layer, you know, area wise, rather than in any kind of sequential left to right kind of fashion.
Before I forget to answer this, there's a question in the chat from Jared who wants to know more about the elastomer resins you were looking for that Formlabs couldn't print that the ZiP can print.
It was less a matter. So, you know, your first order effects as far as speed and throughput on the ZiP, I think we've touched on, and we've kind of compared and kind of what that decision process looked like, at least in my case. The second order, or let's say downstream consideration, is post-processing, right? And that's not trivial. You can spend quite a lot of time hand finishing parts, and you can spend quite a lot of time setting up a build to minimize the supports and how they land, how they touch on the part, and so that's a pretty substantial consideration, specifically with respect to these elastomers, right? You've got some challenges as far as what those supports represent, right? You're dealing with you know, a jiggly piece of rubber for low durometer formulations, and so you've kind of got to bear that in mind to support the part properly, so that you get a part that's good. But then on the trade-off, of course, is that you've got maybe some substantial difficulty with post-processing. And so it's not that the elastomers can't be processed. It's that I would say you kind of have to tread lightly in terms of what you can expect, right? And just again, because you've got these peel forces and this recoding kind of action going on in the Formlabs system, I think there's a real advantage in terms of what you need in terms of adequate support compared to, you know, what you can do with ZiP.
Okay, that's interesting. So you're saying with ZiP you maybe get away with more delicate or more overhangs or more 45-ish degree angles without needing supports, and therefore
Right.
it's easier to design like an elastomer part where you wouldn't really want to put supports on it because they're nearly impossible to remove.
Yeah, so really, and to kind of give some more shape to that sort of remark, if you've ever, you can imagine trying to sand a piece of low durometer rubber, it might not go well, right? So trying to post process those flexible formulations, I think, can be troublesome, or let's call it especially challenging, right? So
Yeah.
you would obviously want to minimize the number of supports, that very advantageous, but you kind of can't, just owing to the
Right.
material characteristics. And so, anecdotally, we're using, it's the ABS, the XABS material, and the support and the contacts are just so light. You can really, really be pretty sparing with that, and that pays dividends in terms of minimizing the amount of post processing downstream. So you would
Mhm.
also get the same benefit for elastomers and for flexible materials.
Okay. So yeah, let's talk more about materials because we're on that. It seems like people are definitely interested in that in the chat. Somebody asked if XiP is an open source, if it's enabled for open source, can you use third-party resins? I can say yes, it is an open platform. So that is another huge difference. I know some people really want that, and I've talked to a lot of people who haven't been able to get that with some of their existing systems. So that's a nice, I think, cherry on top. But we also have, I think XiP has over 20 validated materials from Nexa right now. So we've got a good mix. You can kind of go with either depending on what you need.
Right, and that's I'm glad that that point came up, because again, kind of circling back to the point at which a decision had to be made. The Form 2 had an open mode, and it was kind of, mileage may vary, right? You're taking some risks with that,
Sure.
but to the best that I remember asking about and getting that answered, they completely did away with that for the Form 3. It wasn't even an option. And
Yeah,
so if you were
that's right.
brave enough to try that, you kind of didn't have an option. So that was something that, if you wanted to look at these alternate materials for XiP, you have that capability. You can do that. And I think there's some real value to that.
Yeah, I think that's important too, because I mean, all right, so we have got, let's say we've got a handful of modeling resins, like we've got high speed ones, maybe higher fidelity ones, we've got clear ones, we've got different colors, and then we've got engineering resins of all sorts. Some companies, they have a material that they use in manufacturing, and maybe we don't offer that exact material for every single company. Like and now that they're starting to use these machines, whether it's XiP or NXE, like we talked about before, for production, it's
Mhm.
like that much more important that we give our customers options to go out and use a material that is as similar to what they're using in their current process as possible, right? Instead of
Right.
having to kind of shoehorn themselves into maybe the 20 options or whatever we have, or us having to partner with them and develop every single material under the sun, which we'll get there, but we're not quite there yet.
Well, and so the list of validated materials for the XiP has grown substantially, even in the past 3 months
For
of
sure.
watching it. And that is, as a user of the system, that builds a lot of confidence that, wow, there's really there's a lot of good work being done to kind of broaden the materials portfolio, and
Right.
the partnerships with the resin producers, right? So
Exactly.
very, very encouraging, very exciting.
Yeah. And so the materials you're using are what?
So the material that we initially used on this project, and I wish that I could show it, but unfortunately we're not at a point where that's a possibility to respect the client's privacy. Was Pro 410, and that produced some very crisp, nice sharp edges, high detail, and very fast, right? And
Right.
it made quite an impression as the first material to use. The next material that we ran was the XABS, and again, another very impressive result on that material. Just really tough stuff, impressively so. And I think that's going to be probably the go-to going forward. Another, it finishes very well, it post processes very well. You get to use very light touch points, and relatively sparse supports when you're building with that material.
Awesome. I just thought I would drop a link into the chat here. Some quick spec comparisons. We did created a side by side of the Form 3. I know Paul used the Form 2. He did a lot of research on the Form 3. Obviously it's people know Formlabs. They're one of kind of the leaders and the pioneers in the resin space. So obviously we're trying to bench our printers against some of the most popular out there. And, so we benched against the Form 3 Plus. You can see not only speed, build volume, it's about 25% larger on XiP than with that. So with the Form 3 Plus and print time and all that. But you can go there and check out some of those specs. You were talking about those materials that you're using. We didn't even mention that you haven't even used some of our fastest modeling resins yet, the X45. This is a resin. So we have let's see, XiP has a 4.8 liter build volume, right? So it measures 195 millimeters by 115 by 210. So pretty good size for a desktop. Maybe one of the larger kind of MSLA printers out there. And you can actually fill that entire build volume with multiple parts or one part with the X45 in just over an hour. So we do a lot of like nested print jobs to show that off. But I mean, you're talking about like maybe a part like that tall, a couple inches, or like the size of like an AirPod case, right? Like, I mean, you print it like this, I don't know, five minutes, maybe 10 minutes with our fastest resin. You print it like this, maybe 20 minutes you could print, but you could also print like 20 of these on the build plate and still print that in 20 minutes. So it's kind of hard to comprehend how much throughput you get, right, Paul?
Right, and there's two important points that I want to touch on just to highlight. You kind of get this, quote unquote, economy of scale idea. If you build, let's say if you have one of those parts and it takes 15 minutes, right? And it's, I don't know, make up a number, 55 layers. And then you absolutely pack the build platform with the same number, 55 layers, but let's say the area is completely occupied. Well, you're still looking at the same build time, right?
Yeah.
And certainly for FDM, you don't have that advantage, right? It scales. One part is X, 2 parts is 2X, 3 parts is 3X, really. Even for a long time, it became, well, I should say, it was a little bit of I would say a rude awakening to an extent, because I was expecting a similar sort of outcome with the Formlabs, with the Form 2 machine. And you do see an increase, even if the total number of build layers doesn't change, you do see an increase in build time. Okay. And so it's just kind of interesting, I think, in terms of, on the subject of productivity, right, and throughput, the more that you can pack on that platform, you are going to see a per piece cycle time drop So 45 minutes for, let's say, one part, or 45 minutes for 9 parts, you can drastically cut your per piece cycle time. And then the other thing is that
Mhm.
you've got this 3D stacking and 3D nesting that's available in the software. So
Right.
if you want an extended build, you can really stride toward productivity and output.
Yeah, and so we've done a lot of this testing too. Like we benched against Form 3 Plus, like I said, we've benched against Ultimaker S3, like two of the most popular like professional printers.
Hmm.
And like a stacked out build volume using, we're trying to make it a fair fight. So, right, the absolute fastest draft resin or fastest filament that is with the Ultimaker. And it's simply 6 times faster than the Form 3 Plus. And it's and when you're talking about doing that full build volume print of what would essentially be the Zips full build volume, 6 times faster. So, and then there's the S3, 23 times faster to do the full build volume print. Um, you also get, I think, the resin thing. You get more isotropic parts in general. I mean, you could print solid parts without a speed loss too. So, like when you're talking about FDM, like a lot of prototypes, you're usually using like infills and sparse
Hmm.
fills, and default is typically about 10%. So, I mean, if you really want to go apples to apples and make these dense solid parts, which almost, is pretty rare, I'd say, on the desktop side of FDM,
Hmm.
as somebody who's, used those printers as well, you just don't really see that. Which is kind of interesting.
No, I mean, those are all very important points to keep in mind. As you're contemplating a move to perhaps a different system. You could make an argument maybe that some sort of powder bed fusion system is worth contemplating, but you're talking about a very sharp increase in cost, right?
Right.
And about a process that tends to be well, fairly untidy with
Yeah.
depowdering and all of those considerations.
Right.
So
We do have one of those too. If you're checking, brand new
and
QLS 820,
and they certainly have a
fastest on
place,
the
right?
market.
Right. The mechanical properties are outstanding, but let's say for a small market, for a small office type consideration, I think it would be very difficult to beat the Zip in terms of capability, the materials portfolio, and some of the speed and throughput that you get from the desktop.
Let's talk about the workflow, right? Because I
Mm.
mean, I think if people are used to being in that one ecosystem, moving to another, like what is that transition like? What have been like the differences that you've seen? Has it been very difficult to get up to speed and kind of transition over?
I don't think it could be too much easier, honestly. There's a lot of familiarity there in terms of just the basic functionality of the software. If you're comfortable in Preform, I think you'll just be equally comfortable with the Nexus software. Um, I think Formlabs has tried to build more of an ecosystem, and so they've enabled some multi-user, or let's call it collaborative or cloud-enabled dashboards and things of that nature. But overall, in terms of workflow, I it's very simple. It's very straightforward to start working with Nexus software, and I can't think of any specific difficulties that there are really. It's a very similar sort of approach to prepping your parts.
Cool. Can you just like, I guess, I mean, like go through that workflow process? Like what is Paul Cilino's workflow for design? What CAD do you use, like software to part basically?
Yeah, so typically, I'm not sure that I would call the collection or the stable full of software typical or commonplace. We rely on a number of tools. It's sort of developed out of out of being sort of a necessary evil. And so for conceptual stuff that comes in where we just want to explore shapes rapidly, we use a tool called ANSYS Space Claim and ANSYS Discovery, and it's a direct modeling or direct editing type 3D modeling software that's easy to very quickly explore 3D shapes and kind of work dynamically with a client to approach what it is they're needing. Downstream of that are two parametric, more traditional tools. SolidWorks I've been using for quite a long time, since 1998. So quite a lot of history there. And then Fusion 360 is a great collaborative, sort of still parametric, but maybe some other functionality, and a great collaborative cloud-based, or let's say a cloud-enabled tool. And that's sort of on the front end, right? So the 3D CAD modeling side of things. In the middle is 3D scanning, and that's really kind of a very unique offering, and something that complements the CAD modeling side of stuff for scan-based reverse engineering and scan-based inspection. That's a HandyScan or a Creaform HandyScan Black Elite is the hardware. And behind that is Geomagic Control X and Geomagic Design X. That's sort of the midsection. And then on the tail end of the workflow is our 3D printing capability and KeyShot for doing product renderings and visualizations. So it's pretty well end to end, I would say, from napkin sketch to a deliverable prototype.
Cool. All right. Well, you talked a little bit about, you mentioned your family business. I don't know if you went into detail. So you kind of grew up in the machine shop world, right?
That's right. From I don't know, the age of 13 or 14, it got started, and Dad used to have to kick me out of the place come quitting time, but it was a lot of fun exploring that and learning via hands-on. It's become popular now to get hands-on experience, I think, to complement engineering design. But that was a really rare and very valuable experience to be able to learn that and to have that opportunity.
Yeah, I'm asking. I know because you mentioned we did a case study, and if you're interested, I'll drop the link to for anybody who wants to check out the story on our site about Paul and MotoCilino and his use of XiP, but it's pretty similar to what I'd say we've been talking about today. So kind of the written version, but in that case study, you told me. You talked about the build quality of XiP and kind of, a professional 3D printer versus maybe more of a consumer 3D printer, and how important the build quality is. And as a machinist also, just kind of your personal interest in seeing nice parts.
Yeah, it's I'll say it like this: from the minute that the XiP showed up on the skid and the way it was packed, just the whole unboxing experience was a surprise. It just made such an impression to see the results that everybody there brought to reality. And when I took the build tray out and saw this nicely machined solid aluminum billet part, and there's nothing that's there is nothing about the machine or the system or the hardware that inspires any kind of doubt as far as build quality goes. It is a very solidly built machine, and I can tell from looking at the tool marks on some of the parts that it's definitely quality.
Yeah, that's awesome. And if anybody's kind of looking at XiP, you'll probably notice like some of the key differences that stand out. Just like the door, it doesn't open up. It's not a cantilever kind of acrylic dome that you see with pretty much every desktop resin 3D printer on the market. This one's a little different. It's more of a traditional hinged. I think pretty nice hardware in that too. But the door swings out, it feels kind of like a vault door. It's very heavy. The whole body is very heavy duty, and the Z axis is actually anchored to that aluminum shell from top to bottom, which in a lot of cases you don't have that anchoring on the top, and that's another variable that can introduce, wobble and throw off some dimensional accuracy. I mean, the more of those variables you can control, the better, obviously, right?
Yeah, for sure. And so, to borrow from experience with CNCs and machine tools, there is no substitute for mass and for rigidity. Those are going to pay dividends when it comes to having a piece of equipment that performs and that performs well, right? And aside from just the tangible, enjoyableness at those points, you're going to be inclined to get confidence in the form of dependability, reliability, longevity.
For sure.
And so, I mean, those are all important things to consider.
Cool. Well, we're getting toward the end here. We've only got a few more minutes. We've just kind of been going on and on, which I tend to realize, talking to Paul, he can really dive into the technical stuff, which is, it's always a pleasure to get into the weeds and talk about that. But we've been answering questions all throughout, so I haven't really been holding a bunch up. But if anybody does have any questions they want to add in, go ahead and drop them into the Q&A panel or the chat, and we'll answer some of those now. Paul, can you tell us about any specific like projects? We haven't really talked too much about the specifics. I know like the main one that you bought XiP for.
Right.
I know I've kind of gotten a little sneak peek, but we can't really talk specifics about that. The parts look really good. They actually, even the quality comparison, I was impressed at how good the XiP one looked versus the other one. So, but yeah, do you have any examples of XiP projects you've been working on?
I've got a handful that are sort of in various states of completion. We'll call it like that. But for grins, I've got a couple of legacy parts that I was able to kind of go back and revisit and build, and it's been. I'm anxious to get back to a position where I'll be able to kind of bring some of those, but unfortunately, like I said, they're sort of scattered about at this point, so nothing to show in hand.
Actually, Eliza just threw in a question. What was Paul's biggest surprise about the swap, either good or bad?
Let's see. Biggest surprise about the swap. I would say the biggest surprise was the level of quality, that being certainly a positive, right? I was delighted by that. I was not expecting it. I knew it would be good. I didn't know it would be quite that good. And the speed, for sure, using that Pro 410 was that was a real eye opener. I think in some sense, there's this mental kind of weight that gets lifted because you can just print quickly and you can iterate very quickly. There's that sense of penalty for making a mistake or leaving a feature out of the part and realizing that you're gonna have to wait 10 hours to, try it again. The speed really kind of does enable and encourage iteration.
Sweet. Well, that just about wraps it up for us. We are right on the money at the end here. I do want to mention we do have a 60-day money blah, blah, excuse me 60-day money back guarantee for XiP. So if you are thinking about getting it, it's a good time to buy. You can scan that QR code, get to the page, and take advantage of that. Try it out. I mean, if you don't like it, you can send it back, get your money back. I think you're gonna like it, but why not give it a try? So throw that up there. Want to thank Paul, obviously, for joining. It's been a real pleasure getting to know you, Paul, and chatting with you today. So thanks for carving out some time for us.
Likewise, and thank you so much for the opportunity to share and kind of go over some of those points.
Cool. And yeah, I know we don't have a slide for it, but you can check out Paul's stuff, MotoCilino.com, right?
Yeah,
Um,
yeah, exactly.
and yeah, Paul, if you need engineering design services, I can say that I've seen Paul's work, and it is top notch. So check that out. And yeah, for everybody joining us today, thank you also for carving out some time for us. And you can learn more about all of our products at nexa3d.com. And until next time, we'll see you later.